Hello YouTube students, my name is Vincent and today I want to take a look at the distance formula. I want to look at the problem, use the distance formula to find the length of line segment AB whose endpoints are -3, 1 and 2, -2. So if we start by plotting the point -3, 1, we can label this point A. Next we can plot the point 2, -2. And we can label this point B. And our goal is to find the distance or the length of line segment AB. So we can connect these 2 points, and this is what we're trying to find, is the length of this line segment. So we could use the distance formula. When we have 2 points, x1, y1 and x2, y2, we could use the formula D equals x2 minus x1 squared plus y2 minus y1 squared. So if we're looking at the point -3, 1 and 2, -2, we could designate, let's say A, the point -3, 1 can be our x1, y1. And the point B, 2, -2, can be our x2, y2. So now we could use the distance formula to find the distance or the length of line segment AB. So I'm going to set up the distance formula. We're looking at D equals the square root of, now we have x2 minus x1 squared plus y2 minus y1 squared. So now all we need to do is substitute for x2, x1 and y2, y1. So we have that the distance, or the length of line segment AB, well, we designated point B to be our x2, y2. So we're going to substitute x2, which in this case is the x-coordinate. So we have 2 minus the x-coordinate of point A. So 2 minus -3. See, all we're doing is subtracting their x-coordinates. 2 minus -3. And whatever we get here, we're going to square it. And then we're going to add y2 minus y1 squared. Well, y2 is -2 and y1 is +1. So we have -2 minus 1. This quantity squared. So now in the next line we could simplify. We have that the distance is equal to 2 minus a -3 becomes 2 plus 3. So we're looking at 5 squared plus a -2 minus 1 is a -3. So we have a -3 squared. Next we could simplify further. We have that the distance is equal to 5 squared is equal to 25. -3 squared, or -3 times -3, is equal to a +9. So now the last line will be to write the distance is equal to the square root of 34. And if we were to try to factor this further, we would have 17 times 2, both of which are prime and not perfect squares. So radical 34 is as simple as we could get this distance. And now if we wanted to verify our answer, let's take a look at the Cartesian plane. We could build a right triangle and use the Pythagorean Theorem to find the length of line segment AB. For instance, if we were to drop down this vertical line and then this horizontal line, we could build a right triangle, and the vertical leg will be 1, 2, 3 units long. And the horizontal leg will be 1, 2, 3, 4, 5 units long. So using the Pythagorean Theorem, we would have a squared plus b squared equals c squared. The distance, or the length of line segment AB, would be the hypotenuse, or the c squared value. So we could substitute 3 squared plus 5 squared is equal to c squared, where c squared is going to equal the length of AB squared. So now we have 9 plus 25 equals c squared, which gives us 34 equals c squared, which now to solve for c, we could just take the square root of both sides, and we have that the square root of 34 is equal to c. So the final answer to this problem, which we verified with the Pythagorean Theorem, is that the length of line segment AB is equal to the square root of 34. Okay, well this is going to conclude this distance problem, as well as this video. Thank you all for watching, and I hope that it was helpful.